Hundreds of millions of rocks orbit the Sun within the asteroid belt between Mars and Jupiter, but only some of them come relatively close to Earth. NASA classifies asteroids orbiting within 30 million miles of our planet as near-Earth objects, and inside this group, there are particularly worrisome objects. Those are so large and orbit so closely to our home planet that they could turn into a real threat to the world should a direct collision occur. At the moment, NASA is keeping a close eye on an asteroid named Bennu. It's a fairly large space object that might smash into our planet in 159 years. According to the experts, the asteroid, which was first spotted in 1999, is quite likely to drift into the orbit of our planet. If it happens, it might collide with Earth by the 24th of September, 2182. Asteroid Bennu is thought to be taller than the Empire State Building. If that hits our planet, the collision will release 1,200 megatons of energy. That's an enormous amount of energy that nothing built on Earth could produce. Scientists from NASA believe that during the flyby in the 22nd century, there's a tiny chance that the asteroid will pass through a gravitational keyhole. That's a region of space that might set the space traveler on a certain path, which could result in the asteroid crashing into Earth. Bennu flies by our planet every 6 years. It has had 3 close encounters with Earth in 1999, 2005, and 2011. These days, scientists estimate the chance of the asteroid hitting our planet by 2182 as 1 in 2,700. That's more than 5 times a person's chance of being struck by lightning. But even though Bennu's chance of colliding with Earth are quite low at the moment, the space rock has still been categorized as a, quote, potentially hazardous asteroid, all because it might come as close as 4.65 million miles from Earth. That's the reason why it's also classified as a near-Earth object. Bennu is a carbon-rich asteroid that was formed in the first 10 million years of the history of the solar system. That's around 4.5 billion years ago. No wonder this space body holds precious clues to the origin and development of the rocky planets of our solar system, which are, as you recall, Mercury, Venus, Earth, and Mars. Even better, it may contain organic molecules, similar to those that are crucial for life to evolve. In 2020, NASA's OSIRIS-REx managed to briefly touch the surface of the asteroid. It collected some samples and propelled off the space rock afterward. For NASA, it was the first mission of this kind. But it won't probably come as a surprise that Bennu isn't the only asteroid we should worry about. Asteroid 99942, Apophis, is another space body we'd better watch out for. It's a near-Earth object about 1,100 feet across. It was discovered in 2004, and at first, it was identified as one of the most dangerous asteroids ever detected. Apophis gained notoriety very fast. It was believed to pose a serious threat to Earth. Experts predicted that it would come uncomfortably close to our planet in 2029. Luckily, after a more careful examination of Apophis and its orbit, astronomers concluded that there was no risk of the asteroid colliding with our planet for at least a century. The risk of an impact in 2029 was ruled out completely, as well as the potential impact that could be caused by the asteroid's close approach in 2036. Interestingly, until March 2021, there was a small chance of a collision in 2068. But then, Apophis made a flyby of Earth, and astronomers took this chance to use powerful radars to estimate the asteroid's orbit around the Sun more precisely. This allowed them to rule out any impact risk for at least the next 100 years. Now, the reason why such discoveries make us so worried is that even a relatively small asteroid, the size of a house, can wreak havoc upon colliding with our planet. And if an asteroid is larger than 0.6 miles across, astronomers call it a planet destroyer. The impact energy released by such an asteroid after striking Earth could be devastating. That's why knowing where such asteroids are and in what direction they're moving is crucial. The problem is that our capability to protect the planet from asteroid impacts is not top-notch yet. If such a catastrophe was about to occur, we would need some time to prepare, because an asteroid collision is no joke. Probably the most well-known asteroid impact site is the Chicxulub crater. It's the evidence of the terrifying collision that led to the extinction of dinosaurs. Strangely, this crater isn't very visible, but some others are. For example, Barringer Crater in Arizona, which is also called Meteor Crater. It looks rather blood-chilling when you think about the collision that led to its appearance. In any case, we now know that space rocks hit not only the Earth but also the Moon, Mercury, and Mars. No rocky planet in the solar system is safe from asteroid impacts. That's why we have an entire scientific enterprise whose goal is to find and catalog the asteroid population of the solar system. Now, it might sound a bit scary, but there are around 25,000 asteroids larger than 460 feet in diameter near the orbit of our planet. Such a space rock is large enough to wipe an entire city off the face of the Earth. So far, less than 50% of such asteroids have been detected and tracked. There are also an estimated 230,000 objects equal to or larger than 160 feet in size. Those are capable of destroying a concentrated urban area, and still fewer than 8% of those have been detected. There are also tens of millions of smaller near-Earth objects. They are larger than 33 feet across and might cause some surface damage. Less than 1% of such small space bodies have been discovered so far. Now, the thing is, the inner solar system is extremely challenging for asteroid search. Each night, there are only 2 10-minute windows when astronomers can observe the region, all because the sun's glare creates a very bright background glow. Plus, the atmosphere of our planet also distorts and blurs observations. Spotting asteroids in such conditions is beyond the capabilities of most telescopes. A unique instrument is needed to fulfill this task, and the tool of choice is the Dark Energy Camera at Cerro Tololo Inter-American Observatory in Chile. This device wasn't designed to hunt asteroids. Researchers built it to search for another elusive target, dark energy, the mysterious force driving the expansion of the universe. The DEC is supposed to observe hundreds of millions of galaxies. That's why it's both wide and deep. This way, it can both peer deep into the universe and capture a wide field of view, which helps it record the motions of galaxies and the conditions in the early age of the universe. But it also means that the DEC is perfectly suited to spotting asteroids near the Sun. Inner asteroids are rare, and deep images are necessary because such asteroids are faint. Scientists need to be able to fight both the bright twilight sky near our star and the distorting effect of Earth's atmosphere, and the DEC can help them achieve their goal. The Dark Energy Camera was built to carry out the Dark Energy Survey, which finished in 2019. Now astronomers can direct the power of the camera towards other tasks. They claim that the DEC's survey is one of the most sensitive searches ever performed for objects near Venus's orbit and within the orbit of our planet. It provides us a great chance to find out what kinds of objects are lurking in the inner solar system.
That sound is the explosion of a supersonic wave. The Earth's atmosphere has been invaded by a cosmic rock the size of Everest. It weighs trillions of tons and is flying towards the Earth at an incredible speed of 12 miles per second. It would fly from New York to Anchorage, Alaska, faster than you can fry an omelet. Don't worry, we're safe. The dinosaurs that ruled the planet at the time, however, not so safe. This was a bad day for them. This disaster began in the area we now call the Yucatan Peninsula, modern Mexico. The meteor did make impact on the ocean, but the water did not extinguish it. The collision caused a huge amount of energy to be released, which began a cataclysm on a planetary scale. Imagine another sun lit up on the surface of the Earth. The initial blast actually blew through the surface. It was as hot as an oven and burned everything in its path. It set up a tsunami as high as the Statue of Liberty from the epicenter. The impact also provoked a colossal earthquake and volcanic activity. Several nearby volcanoes simultaneously released hot lava from their calderas. Millions of tons of ash and soot were released into the atmosphere, poisoning the air. This formed a huge ash cloud in the atmosphere, which for several years didn't allow the sun's rays to reach the Earth. The long nuclear winter began. Only it wasn't snow that fell from the sky, but a rain of sulfuric acid. Yes, it's safe to say that Chicxulub is one of the most devastating culprits in the history of our planet. In fact, why don't we have ourselves a trial against this space monster? Let's investigate this 66 million year old crime. Thanks to scientists' efforts over the years, we have plenty of evidence. I'll be the judge. In the name of space law, I give the floor to the prosecutor. Respected judge, jury, today it is obvious to all that it was this asteroid that led to the extinction of our beloved dinosaurs. Some more beloved than others. T-Rex. There are other suspects. Volcanic eruptions, a lot of oxygen in the atmosphere, a supernova explosion, temperature changes, the list is very long. But scientists have, without a shadow of a doubt, determined the truth. This asteroid left a crater on the planet's surface with a diameter of 93 miles and a depth of 12 miles. Though this scar is hidden under the ocean water, it can still be seen today. The perpetrator did attempt to hide evidence, as the temperature at the center of the collision was so hot it vaporized part of itself, but not nearly enough. We know that lots of asteroids are abundant with the material called iridium. The fragments off this rock contain 300 times the normal amount. And research shows these fragments are exactly 66 million years old, just like the defendant. This is the definitive proof of guilt. Furthermore, the defendant knocked 25 trillion tons of hot rock out of the Earth. The debris of the asteroid mixed in with the Earth's material, and the immense heat turned the stones into glass. Scientists call these tektites. The energy of the impact threw them into the atmosphere, and after a short flight upward, the tektites then fell down upon the Earth. It was like a rain shower, only instead of water, it was a rain of hot fireballs. They bombarded the planet's surface for 24 hours and set fire to everything they fell on. Scientists have found traces of them all over the world. These are undeniably shards of Chicxulub. I rest my case. Respected prosecutor, your evidence is very convincing, but our judgment must be objective. We now give the floor to the defense. Your Honor, I believe this is a terrible misunderstanding. My client isn't some space offender. It's simply the victim of cosmic circumstances. In fact, the asteroid Chicxulub isn't even an asteroid, but in fact, the fragment of a comet. These aren't my words. These are the conclusions of a study conducted by a group of astrophysicists at Harvard University. Asteroids are made of stone and metal. Most often, they resemble the shape of a potato. Comets, on the other hand, contain rock, metal, and ice. They look like dirty snowflakes with ammonia, methane, and carbon dioxide mixed in. Most comets come to us from the Oort cloud. This is a large accumulation of ice debris around our solar system. Due to the elongated orbit of flight, from time to time, comets emerge from this cloud. So occasionally a cosmic snowball crosses the barrier and enters our solar system. This is what happened to my client. According to scientists, Chicxulub's flight path put it dangerously near Jupiter, which, with its impressive gravitational pull, accelerated Chicxulub's velocity and put it on a collision course with the sun. The sun's heat then evaporated the comet's outer coating of ice and dust, which formed a tail. But even before making impact, the sun's gravity shattered the comet apart. One of those fragments was the one that flew through space and crashed into the Earth 66 million years ago. Yes, there is some debate among scientists on this hypothesis, but regardless of the details, one thing is certain. My client did not intend to crash into the Earth 66 million years ago. Circumstances conspired it to be so. You're on. All right, I have listened to both sides, and I have made my decision. In the name of the Space Court, I declare that the defendant is acquitted. Well, that was a bit of fun. The truth is that space rocks like Chicxulub are a dime a dozen. There are millions of them bumping into one another in the vastness of space. The Earth was just unlucky enough to be in the path of this one. Though the impact it's had on the planet cannot be overstated, this catastrophe ended the development of 75% of life on the planet. Some marine animals did survive the impact, for example, crocodiles, turtles, and fish. Of the inhabitants on land, the only animals to survive were tiny creatures, no larger than a modern raccoon. Among them are several species of avian dinosaurs, which are actually the distant ancestors to modern birds. Scientists believe they survived for two reasons. First, unlike most herbivores that relied on grass for their diet, these dinosaurs had beaks, which they could use to split nuts and dig out seeds. So even when most of the plant life was gone, they could still subsist on what's left. Secondly, these dinosaurs' brains were larger than those of most. This means that avian dinosaurs could cooperate with each other and quickly adapt to new conditions. Lots of fungi and mold also survived underground and underwater. Gradually, the darkness cleared away, and ferns began to take over the lifeless landscape once again. Thousands of years later, forests reappeared on Earth. One unexpected benefit to this disaster is that it allowed for the emergence of the rat-like mammals that are the ancestors to modern humans, as well as whales, bears, and even the platypus. Back before the incident, these mammals would live in the shadow of their dominant dinosaurs. But their disappearance created a biological vacuum. Thus, these mammals were able to quickly occupy that vacant niche and become the new dominant group on the planet. According to multiverse hypothesis, many parallel worlds exist simultaneously with our own. Let's imagine that this is true and that we found a way to travel to these worlds. Let's board a ship to fly through space and time. Our destination is a universe in which the asteroid flew past the Earth. In this reality, the domination of the dinosaurs was never interrupted. Earthquakes, tsunamis, ice ages, volcanic eruptions, the dinosaurs survived all these minor cataclysms. Most of the lizards have changed and are now unrecognizable. Due to the onset of the ice ages, many dinosaurs here are covered in feathers that protect them from the cold. Mammals also exist, but they're few and far between. You see some bats in caves, and there are many rat-sized rodents in the forests. During the day, they hide in the undergrowth or in burrows. At night, they go out in search of food. There are no horses, elephants, or other large mammals in this world. Why become large and noticeable if there are so many dangerous reptiles with big appetites around? There are no whales in the sea. There are no parrots, hawks, or pigeons in the sky either. But you can see creatures similar to pterodactyls soaring past. Some are about the size of a helicopter, while others are no larger than a swan. There are also primates, but they're in no hurry to climb down from trees and walk on two legs. In our real world, our primate ancestors settled in the savannah, where, because the distance between trees was much wider, they started walking on the ground between, eventually standing upright and evolving into Homo sapiens. In this world, open spaces are still very dangerous, so these primates stayed in the trees and evolved to more resemble a lemur, not a chimpanzee. So of course, humans have never emerged on this planet. This means there are no roads, cities, cars, or space satellites. But flowering plants did evolve, as did many fruit trees. Many small dinosaurs would have evolved to feed on these fruits. This did also happen in our world, back in the Cretaceous period just before the failed collision of the asteroid with the Earth. The dinosaurs of this planet have grown wiser, reaching the level of a modern chicken. But a large brain uses a lot of energy, and enlarging it is not always a good strategy for survival. What's good for a primate in the mammalian world isn't always good for a dinosaur in the reptile world. Thankfully, this isn't our world at all. In our world, that asteroid really did wipe out the dinosaurs. They didn't stand a chance. What's interesting is it wasn't really the size of the asteroid that made the impact fatal, but where and how it hit the Earth. When measuring meteor impact, one important factor is the angle of incidence, which determines the kind of fallout to expect. Chicxulub hit the Earth at a 60-degree angle. This was the worst-case scenario. At that angle, the impact knocked a lot of water vapor and carbon dioxide into the atmosphere, but more importantly, lots of sulfur. This substance stayed in the atmosphere and formed aerosols, which are tiny particles that blocked the sun's rays. Without the sun, plants disappeared and the climate became colder. If the angle of impact was any different, then the dinosaurs could have survived this catastrophe. As cool as dinosaurs are, I'm glad I can go outside and not have to worry about a random raptor attack or a triceratops stampede. So as devastating as Chicxulub was all those 66 million years ago, I guess I'm glad things played out the way they did. We wouldn't be here otherwise. Thanks for watching.
In 2007, astronomers spotted a massive 54-ton asteroid roaming space relatively close to our planet. But later they lost track of it. That's why the space rock was declared a lost asteroid. Almost 2 decades have passed since then. And in November 2023, a report claimed that the lost asteroid, aka 2007 FT3, might hit Earth in 2024. Such news sounds ominous. But how true is it? Well, NASA disagrees. The U.S. Space Agency has refuted the worrying claims. This statement was issued in response to the announcement that there was a 1 in 11.5 million chance of the asteroid striking our planet on the 5th of October, 2024. The space agency states that at any time in the next century, there are no known asteroids that could pose an impact threat to Earth. NASA and other space agencies are watching the skies nonstop, determined to find, track, and categorize asteroids and NEOs near Earth objects. Hundreds of millions of rocks orbit the sun within the asteroid belt between Mars and Jupiter. But only some of them come relatively close to Earth. NASA classifies asteroids orbiting within 30 million miles of our planet as near-Earth objects. Inside this group, there are particularly worrisome objects. Those are so large and orbit so closely to our home planet that they might turn into a real threat to the world should a direct collision occur. Luckily, the larger an asteroid is, the easier it is for our planetary defense experts to find it. The orbits of the largest space rocks around the sun are normally well known and determined for years and even decades. At the moment, NASA is keeping a close eye on an asteroid named Bennu. It's a fairly large space object reaching 1,610 feet across. It might smash into our planet in 159 years. According to experts, the asteroid, which was first spotted in 1999, is quite likely to drift into the orbit of our planet. If it happens, it might collide with Earth by the 24th of September 2182. Asteroid Bennu is thought to be taller than the Empire State Building. If it hits our planet, the collision will release 1,200 megatons of energy. That's an enormous amount of energy that nothing built on Earth could produce. But even though Bennu's chances of colliding with Earth are quite low at the moment, the space rock has still been categorized as a potentially hazardous asteroid. All because it might come as close as 4.65 million miles from Earth. That's the reason why it's also classified as a near-Earth object. Asteroid 99942, 942 Apophis, also known under the dramatic name of the God of Chaos, is another space body we'd better watch out for. It's a near-Earth object about 1,100 feet across. It was discovered in 2004, and at first it was identified as one of the most dangerous asteroids ever detected. Apophis gained notoriety very fast. It was believed to pose a serious threat to Earth. Experts predicted that it would come uncomfortably close to our planet in 2029. Luckily, after a more careful examination of Apophis and its orbit, astronomers concluded that there was no risk of the asteroid colliding with our planet for at least a century. The risk of an impact in 2029 was ruled out completely, as well as the potential impact that could be caused by the asteroid's close approach in 2036. Interestingly, until March 2021, there was still a small chance of a collision in 2068. But then, Apophis made a flyby of Earth, and astronomers took this chance to use powerful radars to estimate the asteroid's orbit around the Sun more precisely. This allowed them to rule out any impact risk for at least the next 100 years.
Living on our beautiful planet might seem safe, but only until you start thinking of all those dangers lurking just around the corner, or in the vast darkness of the cosmos. Let's see what may eventually lead to the end of planet Earth. With each new potential threat, it gets more and more terrifying. Consider yourself warned. First of all, let's talk about hypercane. This natural disaster can get really extreme. A hypercane is a theoretical hurricane of unsurpassed power. It would occur if the ocean became overheated as a result of climate change, or a massive volcanic eruption could trigger it. In any case, these conditions would create a hurricane, which, unlike regular hurricanes, would stretch way beyond the lower stratosphere. The speed of such a storm would reach 500 miles per hour. The pressure inside the hypercane would be so low that it wouldn't let it wear out as quickly as other hurricanes. The hypercane could last for weeks on end. But the worst thing? It would likely damage or even destroy part of Earth's ozone layer, and the hole could be the size of the entire North American continent. Then we've got super destructive tornadoes. A tornado is a violently rotating column of air. It usually extends from a thunderstorm and is in contact with the ground. Inside a thundercloud, warm, humid air rises upward, and cool air falls down along with rain or hail. Such conditions can lead to the appearance of spinning air currents inside the cloud. Interestingly, these air currents start out horizontal, but at one point they can become vertical and drop down from the cloud, becoming a tornado. Some tornadoes are narrow, rope-like swirls, but others turn into wild funnels. Tornadoes are ranked with the help of the enhanced Fujita scale. A weak tornado normally lasts for a few minutes and doesn't move faster than 100 miles per hour. The next level is a strong tornado. Such whirlwinds can last for 20 minutes or so and have winds of up to 200 miles per hour. And then we can also have violent tornadoes. Those can last for more than an hour and move at a speed of between 200 and 300 miles per hour. On average, around 1,000 tornadoes occur in the USA every year. There's even a region that got named Tornado Alley. It's a 10-state area in the Midwest, but tornadoes can happen in any state. One of the most destructive natural disasters was the tri-state tornado in the USA. It was the world's longest-lasting single tornado that traveled 220 miles through Missouri, Illinois, and Indiana. At the same time, the average tornado's path is usually no longer than 5 miles. But what if one day, a tornado much bigger and way more powerful than any we've experienced before swiped through countries and continents? It would leave behind total destruction and devastation. And how about a supercell thunderstorm? It's the least common type of thunderstorm, but it's the most dangerous. It's likely to cause severe weather, damaging winds, very large hail, and even violent tornadoes. What makes supercells unique is a deep and persistent rotating updraft called a mesocyclone. Supercells can potentially last for hours and cause great havoc. An asteroid impact could end all forms of life on Earth too. If a space wanderer was large enough, it could cause widespread devastation, like it happened with the 9-mile-wide asteroid from 66 million years ago. It's rumored to have destroyed 3/4 of the planet's plant and animal species, including dinosaurs. Depending on the asteroid's size and the speed of its approach, the impact could lead to massive fires, tsunamis, and the eternal winter effect. It happens when the debris ejected into the atmosphere blocks sunlight and disrupts the global climate. Luckily, we'd probably notice such a large asteroid coming close to our planet with the help of our equipment long before the collision and would have enough time to get rid of this threat. It would be our very own sun that would bring our world to an end. Our star is a gigantic, constantly changing ball of molten gases. Every once in a while, it spews out bursts of energy, solar flares. They often go hand in hand with something called coronal mass ejections. Those are giant bubbles of ionized gas that can accelerate to incredible speeds. The most powerful volcanic eruptions pale in comparison to solar flares that release 10 million times more energy. Within a few minutes, one solar flare can give out billions of tons of charged particles. Solar flares are also insanely hot, with the temperatures reaching several million degrees Fahrenheit. Astronomers believe that such bursts of solar radiation happen when the sun's magnetic field gets twisted in some regions. At one moment, all the pent-up energy is released. The star sends out light and particles, mostly electrons and protons. Most solar flares last for minutes, but some continue for hours. Scientists classify solar flares depending on how brightly they shine in X-rays. You aren't likely to notice the tiniest flares if you don't have special equipment. Medium solar flares lead to fleeting radio blackouts at the poles, but nothing too serious. It's X-class flares people should worry about. They cause the strongest and longest-lasting solar storms. Now, if you had gamma-ray vision, you'd be able to see immensely bright flashes. They occur every day, outshine everything around you, and then disappear again. Those flashes are gamma-ray bursts. One of them could wipe out Earth's atmosphere. The flash that might ruin our planet would most probably be born in a faraway galaxy during a merge of two collapsing stars. It would be immensely powerful and super bright. Still 1,000 light-years from Earth, it'd already shine as bright as the sun. Our planet's atmosphere would try to protect us, but its natural shield wouldn't last. The radiation would be so powerful that it would literally cook the atmosphere. It would create nitrogen oxides that would destroy the ozone layer. Without this layer, ultraviolet rays coming from the sun would be hitting Earth's surface at full force. They would wipe out tiny plankton in the ocean. But these plankton produce from 50 to 70% of all oxygen in the world. So, with their disappearance, there would be a severe lack of oxygen, which would lead to the disappearance of life on the planet. In the end, the heat and ultraviolet light coming from the sun would turn the planet into a huge chunk of rock. And what if we came across a wandering black hole? You might know that a black hole is a region in space where gravity is so powerful that not even light can escape its clutches. Luckily, the nearest to us black hole is 1,500 light-years away. It seems that we have nothing to worry about until we learn about wandering black holes. Now, things definitely get way creepier. If such a black hole entered the solar system, Earth would be doomed. We wouldn't stand a chance against this space monster. In 2020, 13 wandering black holes were spotted not so far away from our planet. But not far away in space terms means around 1 billion light-years away, so we've got some time left. Plus, the possibility of such a disaster is very, very low. One day, a rogue planet might push Earth out of the habitable zone and into an extreme orbit farther from the sun. Then, the climate all over the planet would start getting colder and colder. Don't forget that the farther our planet is from the sun, the weaker the star's gravitational pull on our planet is. In the end, our beautiful Earth would get too far away from its main source of light and heat. It would turn into a lifeless piece of rock covered with a thick layer of ice. Or the sun might expand and turn into a red giant. If it happened, it would change the entire habitable zone of our solar system. The disaster would start with our star running out of hydrogen in its core. This would trigger a chain of reactions, which would eventually lead to the core of the sun heating up and getting denser. As a result, the sun would get way larger than it is now. During this transformation, the sun would swallow Venus, Mercury, and Earth.